So imagine handing an autonomous AI agent the master keys to your Shopify store, right? And within 3 seconds, it misinterprets this completely vague customer prompt
Yeah.
and just accidentally triggers a 90% off flash sale on your entire fall inventory.
Yeah, which is literally the nightmare keeping technical founders awake right now in mid-2026. I mean, you see all these headlines about agentic commerce taking over, and your immediate instinct as an engineer is just pure terror.
Terror and honestly exhaustion. You hear that AI assistants are going to be negotiating with shoppers in real time, and you immediately think about the thousands of engineering hours it's going to take to rebuild your entire platform to, talk to these things safely.
Right, which is just exhausting to even think about.
Exactly. But for this deep dive, we're pulling from two incredibly practical, zero fluff sources that completely dismantle that assumption.
Thank goodness.
We're looking at a June 10th, 2026 engineering blog post from aspidan.dev. They're the team behind the Shopify app Discount Prime, and it's titled Building an MCP Server for a Shopify App.
Yeah, and we're also pulling from its companion playbook, which is called the Merchant Map.
Right. And our mission today is to just cut through all the model context protocol jargon. We want to give you a concrete, practical mental model for exposing your app to AI without tearing down your code base, and importantly, without accidentally bankrupting your merchants.
Which is always the goal, right? And the beauty of these sources is really how they treat the problem. They completely ignore the theoretical sci-fi fluff of AI and focus entirely on the cold, hard mechanics.
Yeah. Okay, let's unpack this because integrating the Model Context Protocol, or MCP, into your architecture, it isn't about bulldozing your existing fully functional restaurant just to build a robot-only facility.
No, not at all.
Your restaurant works, you have a kitchen, the recipes are good, the human customers are happy. Building an MCP server is really just installing a highly specific, highly efficient drive-through window on the side of the building.
I love that. If we connect this to the bigger picture, that analogy highlights the most critical constraint for any technical founder today, which is efficiency.
Right, time is money.
Exactly. Knowledge of MCP is only valuable if you know exactly where to apply your engineering effort and, honestly, what distractions to ignore completely.
Yeah, because understanding the structural reality of how these agents communicate, it prevents you from wasting 6 months over engineering a system when really a surgical adaptation is all the market actually demands.
Precisely. So let's talk about that structural reality. The Aspidan playbook makes this really bold claim early on. They state an MCP server in a Shopify app context is merely a thin layer.
A thin layer. But a thin layer is still a layer, right?
Sure, yeah.
Like if I'm already maintaining this monolithic GraphQL API or some complex set of microservices, my immediate worry is just operational overhead.
Right, the deployment headaches.
Exactly. Are we talking about spinning up separate Kubernetes pods, managing new deployment pipelines, and dealing with all this network latency between my core app and this new AI translator?
Well, here's the thing. The deployment shape is entirely up to you and the AI agents. They honestly couldn't care less how you handle it.
Wait, really? They don't care at all?
Not even a little. I mean, if you have a massive enterprise application, maybe you do run your MCP server as a separate microservice or like a sidecar proxy. But if you have a leaner app, you could just run the MCP logic inside the exact same Node or Ruby process you're already running.
Oh, wow. So you don't necessarily need a whole new infrastructure.
Exactly. The protocol does not dictate your infrastructure. The AI agents only care about the interface shape.
Okay, so the interface shape being the specific menu you post at that drive-through window we talked about.
Yeah, exactly. They look at the specific tools your server advertises,
Yeah.
the precise JSON parameters those tools accept, and, the format of the responses.
Right.
As long as that interface strictly adheres to the protocol, the agent doesn't know or care if it's hitting a massive server farm or just a tiny single-instance background worker. It just wants its structured data.
Okay, that makes sense. So if we are just opening this drive-through window and pinning up a menu, what is the very first request we actually let the AI make? Like if I'm an engineer sitting down on a Monday morning to build this, I want to know step one.
Well, the directive from the source material is pretty blunt here. It requires developers to just set their egos aside.
Uh-oh.
Yeah, you start with something intentionally unambitious. You build a strictly read-only endpoint.
Read-only.
Just read-only. For a discount app like the one in our source, the very first tool you expose simply answers the query, what promotions apply to this cart?
Okay, I have to say, that feels incredibly underwhelming. I mean, after all this hype about autonomous negotiating AI agents, our big strategic move is just letting them read a database table.
I know it sounds boring, but simple is actually deceptive here. Answering what applies to this cart requires taking a complex payload, like the line items, the customer's tags, the sales channel, and evaluating it against a merchant's entire campaign logic.
Right. I guess it is actually a pretty heavy lift under the hood.
It is. And the source outlines 3 vital reasons why this boring, unambitious endpoint is actually the perfect minimum viable product. First off, it is entirely safe.
Safe because there are zero side effects, right? Like the agent is just asking for a quote, essentially.
Exactly. There is zero risk of it creating a rogue discount code or accidentally changing a setting. The merchant's worst nightmare is completely mitigated on day 1.
Okay, that's a huge relief. What's the second reason?
Second, it is deterministic. Given the exact same cart input, it always returns the exact same discount output. And we'll see why agents ruthlessly enforce determinism in just a minute.
Okay, and the third?
Third, it's genuinely useful. I mean, what applies to this cart is the foundational question any AI shopping assistant must ask to figure out if an offer is even competitive.
Oh, right, because if the agent is trying to convince a shopper to complete a purchase, it needs to know if there's like a 15% off hook it can actually use to close the deal.
Exactly. And shipping just this one boring, safe endpoint, that alone puts NCAP ahead of 90% of the ecosystem right now in mid-2026.
Okay, so let's say we deploy that read-only menu tomorrow. My immediate fear as a founder is that anyone with an internet connection, or worse, my direct competitors, can now just spin up an agent to constantly scrape my proprietary discount logic and merchant data.
Oh, yeah.
So how are we securing this window?
Well, that brings us to what the Playbook calls the day 1 disasters. The first massive mistake developers make here is conceptual.
How so?
Because we interact with tools like ChatGPT in an open conversational UI, developers unconsciously treat these agents as public, unauthenticated entities. They leave the MCP server open, assuming it's just processing public data.
But in an e-commerce environment, these agents are performing actions on behalf of specific users, right? Operating within specific merchant storefronts.
Exactly. They require the exact same rigorous access control you would enforce on any traditional API call. Your MCP server needs to authenticate the incoming agent request as acting on behalf of a specific Shopify store, validating its session token before it even looks at the request payload.
Wait, so why can't I just authenticate the agent, hand it a generic overarching API token, and call it a day? I mean, managing granular OAuth scopes for every single tiny action an AI might take sounds like an absolute nightmare to maintain.
Well, this raises an important question. If you take the lazy route and demand a broad master key scope for your entire MCP server, you hit the second day 1 disaster. MCP operates on tool-level access pattern.
Level. Okay.
Yeah, the platforms hosting these agents, whether it's Shopify's internal routing or a third-party LLM provider, they evaluate risk based on what you ask for.
Meaning if my app only reads prices, but I ask for write access to the entire store inventory just in case I build a new feature later, the platform panics.
Yes. The platform will effectively shadow ban your app. I mean, they are not going to surface a third-party tool to their merchants if it demands write access to campaigns merely to read a discount code.
Makes total sense.
You have to isolate every tool. A pricing lookup gets a price read scope. A tool that creates a loyalty reward gets a reward write scope.
So it's like the bouncer at the door checks your ID and then tells you explicitly you are allowed to look at the menu, but you absolutely cannot touch the cash register.
That is the perfect way to put it.
So once we secure the door and the AI agent is interacting with our specific tools, we hit a completely different operational wall. The sources highlight that AI agents are, without a doubt, the most demanding, repetitive, and annoying customers an API will ever serve.
Oh, they are ruthless.
Yeah. They call your server vastly more times than a human user would for the exact same task.
Right, and this is a byproduct of how large language models actually break down reasoning steps. For a single user request, say, a shopper asking, can I get a discount on these boots? The agent doesn't just hit your server once.
How many times does it hit it?
Well, it queries your MCP server during an initial planning phase to explore available tools. Then, a few seconds later, it queries you again during a verification phase to ensure it formatted the parameters correctly.
And then?
Finally, it queries you a third time right at checkout to confirm the state hasn't changed.
Oh my God, it is exactly like having a micromanager boss who asks you the status of a report 3 times in 10 minutes.
Literally exactly like that. And the playbook notes that if your answer changes even slightly between those redundant questions, the AI completely loses its mind.
Really?
Yes. The agent interprets slight data variations not as a simple update, but as your server being fundamentally unreliable. Like if your database latency causes a timeout on the second request, or maybe a background job alters a campaign rule between the first and third request, the AI just flags your tool as broken.
Wait, so what is the penalty for being flagged as broken? Does it show a pop-up error to the merchant?
No, the penalty is silent and severe. The agent will either aggressively cache the first answer it received and completely refuse to query your live data again, or it will simply route around your app entirely.
Route around it.
Yeah, it will try to solve the shopper's problem using a completely different tool or just a native Shopify feature.
Right.
Your app silently stops receiving traffic.
Wow, okay, hold on. The source recommends fixing this flakiness with rigorous caching, specifically using a cryptographic hash of the exact request input to guarantee the same response.
Correct.
But if we are aggressively caching responses based on a cart's input, aren't we risking serving stale data to the agent? Like, what if a flash sale expires literally while the agent is in its planning phase?
Right, that's the danger.
Or what if inventory for an item drops to zero? Caching seems incredibly dangerous when we are dealing with live inventory and pricing.
Well, you are identifying the exact friction point that separates a toy MCP server from a production-grade one. Aggressive caching only works if it's paired with surgical invalidation events. You cannot use time-based expiration, like clearing the cache every 5 minutes. You have to break the cache explicitly when the real-world state changes.
So we are tying our caching layer directly into Shopify webhooks then.
Exactly. You listen for the exact events that matter. If a merchant updates a campaign rule in their admin dashboard, you immediately invalidate the cache for any cart that might be affected.
And if the shopper adds a new item to their session?
The cart hash changes, so it naturally bypasses the old cache anyway. Determinism in the eyes of an AI is a literal trust signal. If you serve erratic data, the machine fires you.
Wow.
But if you serve fast, stable, reliably invalidated data, the machine leans on you.
Okay, so we have our foundation. The menu is read-only, it's secured with granular scopes, and the caching is bulletproof so that AI trusts us. We're finally sitting at the table.
We are. But reading a menu doesn't make you irreplaceable.
Right, and here's where it gets really interesting. Because the playbook introduces a mantra for the next phase. They say, a read-only server is table stakes. A recommend server is a moat.
Yes. Building the read-only endpoint proves your engineering team can speak the protocol. But transitioning to a recommend endpoint completely alters your software's value proposition.
I need a concrete scenario for this. Walk me through exactly what recommend capable means when a machine is making the request instead of a human clicking a button.
Sure. Let's visualize a specific shopping cart. A customer has, say, $180 worth of merchandise. Instead of the AI agent asking our basic question, what active discounts apply to these items, the agent uses the recommend endpoint to ask a much more strategic question.
Which is?
What is the best offer you can generate for this cart to push the average order value over the $200 threshold without breaking a 40% margin floor?
Oh, wow. So the agent is basically offloading the complex strategic math to the app.
Exactly. The burden of optimization shifts entirely to your servers. Your app can no longer just run a simple database query. It has to actually calculate the cost of goods sold for those specific items.
Yep.
It has to evaluate complex discount stacking constraints. It might realize that offering a flat 10% discount ruins the margin, but dynamically bundling a $25 accessory for $5 hits the $200 target perfectly while preserving profitability.
And then it calculates that specific recommendation and hands it back to the agent.
Exactly.
The app transforms from a static reference document into an active, real-time optimization engine.
Yes, and the AI agent stops merely reading your app and actually starts relying on your app's intelligence to make the final negotiation decisions with the shopper.
See, that is the definition of a defensive mode. Building a basic lookup tool, that takes a few weeks. But architecting an engine that can dynamically calculate margin-optimized recommendations on the fly, that requires intense domain expertise and really deep integration with store data.
It does. And the source boldly states that most third-party developers will simply never invest the resources to build that second endpoint.
Leaving the field wide open for the few apps that actually do.
Precisely. They become the exclusive strategic partners for AI agents within the Shopify ecosystem.
But building a margin-optimizing engine sounds like a 6-month roadmap. Before developers even attempt to cross that moat, they're going to face a lot of friction. The Aspedan Playbook lists 3 specific traps that engineers obsess over on day one, which are actually complete distractions.
Yeah, maintaining momentum in the first month is critical, which means deliberately ignoring certain problems. The first trap is protocol version politics.
Right, because MCP is a really young, evolving protocol.
Exactly. And engineers love to future-proof their architecture by guessing where the specification is heading. But the advice here is strict. Do not anticipate the spec.
So just stick to the current version.
Yes. The core request-response pattern for tool calling is stable. Just ship against the current version. The migration path will be totally trivial for a thin layer later on anyway.
Okay, that makes sense. And the second distraction is tooling and language choice. Because my developer Slack channels are constantly flooded with arguments claiming you absolutely must use Python if you're building anything related to AI.
Oh, I see that all the time. And it completely ignores the architectural reality we established earlier.
Right, the thin layer.
Exactly. Your MCP server is a thin translation layer. It does not run neural networks. It just parses JSON. So use whatever language your core application is already written in.
So if your Shopify app is a massive Ruby on Rails monolith, just write your MCP layer in Ruby.
Yes. If you use Node, stick with Node. Introducing a brand new tech stack just to handle a translation protocol introduces massive operational debt for absolutely zero long-term benefit.
So true. Okay, the final trap involves semantic alignment. Developers will build a tool, test it, and then realize that the ChatGPT agent, the Google Gemini agent, and some open source model all interpret the tool's description slightly differently.
Yeah, that happens a lot. One model might consistently pass a string, while another tries to pass an integer for the exact same parameter.
And the temptation is to spend weeks writing perfectly agnostic, bulletproof code that pleases every single model on the market.
Which is a huge trap. The Playbook advises strongly against this. AI is just messy right now. You optimize your tool descriptions and...
Wait, 4 to 6 weeks? You were talking about like 1 or 2 sprint cycles.
Yep, it's really fast.
But shipping it doesn't mean an instant spike in metrics, does it? Like, you aren't going to deploy this on a Friday and wake up on Monday with a doubled user base.
No, you definitely will not see an immediate traffic explosion. What you are purchasing with those 6 weeks of engineering time is option value.
Option value.
Yeah, because agentic commerce adoption is not some monolithic event. It is rolling out category by category.
So it's basically a positioning play. You are securing a seat at the table before the meal is even served.
Exactly. When the adoption curve suddenly crosses the threshold for your specific category of apps, these autonomous agents will sweep through the ecosystem looking for tools to solve merchant problems.
And the apps that have exposed an MCP interface will be the only applications those agents can natively understand and interact with.
Yes. The apps without an MCP server simply won't exist to the AI. The machine literally will not know how to pull their levers.
That is wild. So you are eating the 4 to 6 week engineering costs right now, while it's cheap and expectations are low, to secure a massive, insurmountable positioning advantage when the wave actually hits your merchants.
You build the table stakes today, securing your option value, which then buys you the luxury of time to build the complex recommend mode tomorrow.
You know, the mental shift required here is profound. Navigating the AI frontier as an app developer, it doesn't mean abandoning the software you've spent years building.
Not at all.
It requires restraint. It means building mechanical trust with machines through strict cache determinism. You start with a small, safe drive-through window, and eventually you evolve into an active optimization layer that the machines just implicitly rely on.
Right. And, the Playbook actually leaves us with this lingering implication about the nature of that machine trust, which I think is fascinating.
Oh, what is it?
Well, we discussed how heavily AI agents penalize flaky, non-deterministic data, right? And how quickly they will just route around an unreliable server.
Yeah, the silent firing.
Exactly. So if machines are increasingly handling the negotiation and execution of e-commerce tasks, what happens to app discovery? I mean, for the last decade, a Shopify app's success has been almost entirely driven by human-written App Store reviews.
True. 5 stars from a merchant meant everything.
Right. But if the machines are the ones choosing, Which app's tools to invoke based on API latency, cache hit rates, and deterministic responses? Will the future of app discovery be dictated entirely by silent algorithmic evaluations of our infrastructure?
Oh, wow.
Could the traditional human-written app review be on the verge of total obsolescence?
That's a terrifying but amazing thought, because when the machines are doing the shopping, they're also doing the hiring and firing of the tools. You better make sure your drive-through window is open and that you're handing them the exact right order every single time.
Every single time.
Well, thank you for joining us on this deep dive into the architecture of agentic commerce. Keep questioning the systems you are building today, and we will catch you on the next one.